Myself, Ashwini Sulad, studied in BSc first year, Sri Siddheshwar Government First Grade College and PG Study Center, Nargond. My topic Atomic Structure Revive of Rutherford's Atomic Model. Content Define Rutherford Atomic Model, Rutherford's Alpha Scattering Experiment, Observations of Rutherford's Alpha Scattering Experiment, Rutherford's Atomic Model, Limitations of Rutherford Atomic Model. Define Rutherford Atomic Model. Rutherford Atomic Model. The Fulm-Fuding model given by J.J. Thomson failed to explain a certain experimental results associated with the atomic structure of elements. Ernest Rutherford, a British scientist, conducted an experiment and based on the observations of this experiment, he explained the atomic structure of elements and proposed Rutherford's atomic model. Rutherford's alpha scattering experiment. Rutherford conducted an experiment by bombarding a thin sheet of gold with alpha particles and then studied the trajectory of these particles after their interaction with the gold foil. Rutherford, in his experiment, directed high energy streams of alpha particles from a radioactive source at a thin sheet 100 nm thickness of gold. In order to study the deflection caused to alpha particles, he placed a fluorescent zinc sulfide screen around the thin gold foil. Rutherford made a certain observations that contracted Thomson's atomic model. Observation of Rutherford's alpha scattering experiment. The observation made by Rutherford led him to conclude that a major fraction of alpha particles bombarded towards the gold sheet passed through the sheet without any deflection, and hence most of the space in an atom is empty. Some of the alpha particles were deflected by the gold sheet by very small angles, and hence the positive charge in an atom is not uniformly distributed. The positive charge in an atom is concentrated in a very small volume. Very few of the alpha particles were deflected back, that is, only a few alpha particles and nearly 180-degree angle of the deflection. So, the volume occupied by the positively charged particles in an atom is very small as compared to the total volume of an atom. Rutherford atomic model. Based on the above observations and conclusion, Rutherford proposed the atomic structure of elements according to the Rutherford atomic model. The positive charge and most of the mass of an atom is concentrated in an extremely small volume. He called this region of the atom as a nucleus. Rutherford's model proposed that the negatively charged electrons surrounded the nucleus of an atom. He also claimed that the electrons surrounding the nucleus revolve around it with a very high speed in a circular paths. He named these circular paths as orbits. Electrons being a negatively charged and nucleus being a densely concentrated mass of positively charged particles are held together by the strong electrostatic force of attraction. Last one, limitations of Rutherford atomic model. Although the Rutherford atomic model was based on experimental observations, it failed to explain a certain things. Rutherford proposed that the electrons revolve around the nucleus in fixed paths called orbits. According to Maxwell, accelerated charged particles emit electromagnetic radiations, and hence an electron revolving around the nucleus should emit electromagnetic radiation. This radiation would carry energy from the motion of the electron, which would come at the cost of shrinking of orbits. Ultimately, the electrons would collapse in the nucleus. Calculations have shown that as per the Rutherford model, an electron would collapse into the nucleus in less than 10 to 8 seconds. So the Rutherford model was not in accordance with the Maxwell theory, uh, and uh, and could and could not explain the stability of an atom. One of the drawbacks of the Rutherford model was also that he did not say anything about the arrangement of electrons in an atom, which made his theory incomplete. Although the early atomic models were inaccurate, inaccurate and failed to explain a certain experimental results, they formed the base for future developments in the world of quantum numbers. Thank you.